Good morning friends. Welcome back to Parnika tutorials. In the last few lectures, I have discussed about the stack and its applications, and also I have discussed C programs to implement the stack using arrays and linked list. I hope you have watched those lectures. In this lecture, I want to discuss about queue and its application in detail. So I request everyone to watch the complete video for better understanding. First, let me define what is a queue. Queue is a linear data structure where operations such as enqueue, dequeue, display will be followed in a certain order. First, let me discuss what is an enqueue operation, dequeue operation, then I will discuss what is that certain order, then I will discuss the applications of the queue. So, we have certain operations such as enqueue, dequeue, display, even we have the peak. These are the four operations we will have in the queue. What is meant by enqueue? Inserting an element into the queue is called enqueue operation. When it comes to the stack, inserting an element into the stack we will call it as a push operation. Whereas in the queue, inserting an element into the queue, we will call it as an enqueue operation. When it comes to the dequeue, deleting an element from the queue is called dequeue operation. When it comes to the stack, pop we will call it as deleting an element from the stack. Okay. Now coming to the display. Display is we are displaying the elements from the queue. And peak is that finding the front element in the queue. When it comes to the stack, topmost element we will call it as a peak. But when it comes to the queue, finding the or displaying the front element which is there in the queue. Now first let me represent the queue. When we are discussing about the stack, we have represented the stack like this, where the insertion and deletion will be done from only one end. So that's why the stack uses the principle called first in, last out, or last in, first out principle. When it comes to the queue, we will represent the queue like this. The insertion and deletion will be done in different ends. So the insertion will be done from this end. Insertion we should call it as a enqueue operation. Deletion or the dequeue will be done from this end. Okay, so this we will call it as a front and this one we will call it as a rear. Okay, usually you would have seen the queue in various applications. Suppose let's take that you went to the bank to withdraw your money. Then there will be a queue, you will be standing in the queue, okay, and then one by one people will finish their work and then finally you will come out. So remember one thing, can you go into the queue in middle? No, they will kick you. Am I right or wrong? So always if there are 4 members are there in the queue, okay, now you are entering. You should be there. See, this is the first person, this is the second person, this is the third person, this is the fourth person. Now here some bank person is there who is giving the cash. Okay, so one by one the people are going. Now you have entered. You should enter here only. You cannot enter here. They will throw you out if you start entering here. Is it clear? So first this person will complete its task, then this person, then this person, then this person, then your turn will come. So always the insertion or the enqueue operation will be done from the rear and the dequeue operation will be done from the front. So this is the difference between the stack and queue. Now with this one you can say that queue follows the first in first out principle or last in last out principle. Suppose let's take that you have inserted the elements such as 1, 2, 3, 4. Then which element you can dequeue first? This is the element you can dequeue because this one will complete its task because the deletion can be done from the front. Now remember one thing, the front will be always pointing to the first element and rear will be pointing to this element, the last element. Is it clear? Are you able to understand? So that any new element if you want to insert, you can insert from the rear, and any element you want to dequeue can be done from the front. So this is about the queue and how it is different from the stack. Now let me discuss few points related to the queue. Okay. Now listen carefully. The queue logically we will represent like this. Okay. Let me take an integer array called A of size 5. Okay. Now you know that array index will start from 0, 1, 2, 3 and 4. So that you can store 5 elements into the array A. Now as the array is empty now, or if you take it as a queue, how can you say that queue is empty? Is that initially we initialize the front is equal to -1 and rear is equal to -1. Okay, then you can say that queue is empty. Now if you want to enqueue the element called 2, are you able to understand? Enqueue 2 meaning is that you want to insert the element 2 into the queue. Then where you will insert? You will start inserting from here and then it will come here. Are you able to understand? Now remember one thing. Sir, you said insertion should be done from the rear. Yes, I agree. But it should be there here. Why you are keeping here? Remember one thing. In general also, if the queue is empty, you are the first person entering into the queue. Will you wait here? You will go directly here and talk with the corresponding person. If you are going to the bank, you will talk with the bank manager or someone. Then you will finish your task. You will not wait here. Once you have entered into the queue, you will directly go at the starting if no one else is there. Am I right? So in this case, when the first element is inserted, where you have to insert? We said it will be inserted here. But how it will happen is that as the queue is empty and you want to insert the element 2, which is the first element, then you will make front, let me write it as F, representation of the front, and rear will be equal to 0. So this is the element you will do. So at A of rear, you will insert this element where rear value is 0. So A of 0 location, where A is the name of the array and 0 is the index and 2 is the element you want to enqueue. Is it clear? Now you want to enqueue the element now 20. Okay. Then how you will do is that again you will increment the rear. Okay, or let me take it as rear only, let me take it to avoid the confusion. Now front is equal to 0, rear is equal to 0. Now what I will do, first I will increment the rear. Rear was 0. Now if I increment it, rear value will become 1. Then I will say A of rear is equal to 20. So now rear value is 1. So it is pointing here. Rear is pointing to this one at the index 1. There you are inserting the value 20. Again you want to enqueue the element some 30. Then again what you will do? You will increment the rear value. Then at the A of rear you will insert the value 30. Is it clear? This is what you will write. Then you want to enqueue the element 40. Okay. Then what you will do? Again you will increment the rear. Now rear is pointing here, rear value is equal to 2. Again you will increment the rear value. Now the rear value will become 3. At the index 3, you are inserting the element. Similarly, you want to insert the 50, NQ of 50 you have written. So rear plus plus. Now rear value is 3. Now rear value will become 4. It is pointing to the index 4. A of 4, you will write the value 50. Is it clear? So now the queue is full. How can I say that queue is full? Because the size of the array is 5. If rear is equal to size minus 1, then I can say that queue is full, because in a queue of size 5, I can store only 5 elements I have stored. So now the queue is full. So this is the condition to check whether the queue is full or not. And this is the condition. So if queue is empty or not, how you will check? If front is equal to -1 and rear is equal to -1, then you can say that Q is empty. If rare is equal to size minus 1, where size is the array of size, then you will say that Q is full. Now, we will discuss how can we perform the DQ operation. DQ operation is nothing but deleting an element from the Q. I just call the DQ function. Then what will happen? We already discussed that DQ will be performed from the front and insertion or the NQ operation will be done from the rear. Now, how can you delete it? Now, the front is pointing here. You will write front plus plus. Then front value is 0. If I write front plus plus, front value will become 1. Is it clear? So now it is pointing here. So logically you have deleted this element. Are you able to understand it or not? So the element which is there at the front was deleted. Now front is pointing here. Are you able to understand? Now you have performed again the DQ operation. Okay, again front value will be incremented. Now front will become 2. Now it is pointing here. Logically you have deleted this element. Then again you have written the DQ. Okay, front plus plus, front value will become 3. Now it is pointing here. So logically you have deleted this element. Again if you call the DQ operation, so 4 times you have written the DQ operation, again front plus plus. Whenever you are calling the DQ, you have to increment the front. So front value was 3, now it becomes 4. So it is pointing to the element which is there at the index 4 of the array. So you have logically deleted this element. Now look at here. How many elements are there in the Q? Only one element is there. Now let's take that you have called the NQ of 60. You want to insert the element 60 into the Q. Now look at here. You can say that so logically you have deleted these elements. So whether Q is full right now or not, Q is not full. How can you say that Q is full? Because these elements are empty or these indexes we have deleted logically. So whatever the 60 you want to insert, you can insert here. That is what you will say. But before inserting, you will check the condition. What is the condition to check whether the Q is full or not? If rare is equal to size minus 1, then we said that Q is full. Now look at what is the rare value. Rare value is 4. And what is the size value? 5. So rare value is equal to 4 and size value is 5 minus 1, because we said rare is equal to size minus 1. So if rare is equal to size minus 1, 4 is equal to 4. This condition is true. If this condition is true, again the Q is full. So that is the limitation with the Q. Okay, this limitation we can overcome with the help of the circular Q. I will discuss about the circular Q in the coming lectures. But look at the drawback of the simple Q. What is it is, even these indices, there are no elements, we have logically deleted. If you want to perform the NQ, we cannot do it. Is it clear? Because the rare is equal to 4, which is size minus 1. So the single Q or a simple Q will say that the Q is full, however we have some elements are empty, but however we cannot insert the element inside the Q. Is it clear? So this is the limitation of the Q. Now look at this one. Again you have called the DQ. Okay, you have inserted the 5 elements. We have called the DQ 4 times. So only one element is there. Now front is equal to rare. What is the value of front? Front value is 4, rare value is 4. Am I right? So if front and rare are equal, then you can say that only one element is there in the Q. When front and rare is equal to 0, only one element is there, that is at the index 0. Now front is equal to 4 and rare is equal to 4, only one element is there at the index 4. Is it clear? So if you call the DQ operation, meaning is that you have deleted this one also. That is what the DQ. Then Q is empty. Am I right? If you deleted this element also, now Q is empty. Now how can you say that Q is empty? you have to make the front and rear equal to -1. So if front is equal to rear, then only one element is there. If you call the dq operation, then logically the q is empty. So again you have to initialize the front and rear is equal to -1. Please remember these points. Anyway, I will discuss these concepts in the coming video and I will write the C program also. So I hope you have understood how we will perform the NQ operation and DQ operation. What is the condition to check whether the Q is full or not, or Q is empty or not. Now I want to discuss about the display. Suppose let's assume that you have the elements 10, 20, 30 is there. If 10, 20, 30 is there, where front will be pointing? Front value will be 0 and rear value will be equal to 2. Now if I say display, sir, the values will be displayed 10, 20, 30 or 30, 20, 10. Which way it will be displayed? Now look at this one. Which element you have inserted first? 10 you have inserted first, then you have insert 20, then 30. Am I right? So when you are displaying the elements, you should display from the front and up to the rear. So the elements will be displayed in this order only, 10, 20, 30. In which order you have inserted, while you are displaying also, it should display in the same order. Okay, so it will start from the front and it will go up to the rear to display the elements. Now let me discuss the next one, peak. Okay, what is this function peak will do is that these are the user defined functions. We have to write the program. Now peak will find the element which is pointing by the front. Okay, so front is pointing to the element 10, which is index at the index 0. So that element will be displayed. So now it will display the value 10. When it comes to the stack, it will display the topmost element from the stack. But when it comes to the queue, at the index of the front, what element is there, that element will be displayed as an output. So these are the basics of the queue. Okay, now let me discuss the applications of the queue, where we can use the queue. We already discussed about the applications of the stack. Am I right? So now let me discuss about the applications of the queue. Usually the queue will be used whenever you want to do the resource sharing. Okay, like CPU scheduling, okay, disk scheduling. In all this way, you will use the queue. And even let me give it a simple example. You have a printer, okay, then printer is there in a particular lab, okay, then n number of scholars are sitting. Let's take that 4 scholars are sitting in this lab and only one printer is there. Now person 1 is giving for the print, person 2 is giving for the print, person 3 is giving for the print, okay, at the same time. Then the person who has given the first, even in milliseconds it will be different. So which person has given the print instruction, that person printout will come, then printout of the person 2, then printout of the person 3. So first P1 has given the instruction, then P2 has given the instruction, then P3 has given the instruction. The printer will print the P1's printout, then P2's printout, then P3's printout it will give. Even we can use this queue in the CPU scheduling and disk scheduling also. When I discuss about the CPU schedulings in the operating system course, you will understand in a better way. Then even you will use this one in the BFS graph traversal also. Whereas the stack we will use it in the DFS, whereas the queue we will use in the BFS, which is a graph traversal, okay, breadth first search, and this is the depth first search, okay. In those traversals we will use the queue. So these are the applications of the queue, and I have discussed about the basics of queue. If you still have any doubts related to the concepts which I have discussed, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. In the next video, I will discuss about how to implement the queue using the arrays. Thank you for watching the complete video. Have a nice day.